Now that we have talked about the different types of bearings, let's look at some examples on calculations of angles and bearings. Before we do the calculations, please take note that for angles, we still use the traditional way of talking about them. So in a way, or in a sense, 1 degree is actually 60 minutes, and 1 minute is equals to 60 seconds. Alright, so 1 minute is equals to 60 seconds, 1 degree is equals to 60 minutes. So let's look at a few examples on calculations of angles and bearings. Let's look at this example. If you are moving from point M to point L, and you have measured this particular angle to be 140 degrees, 30 minutes and 20 seconds. You want to find the backward bearing of the line ML. So remember, if you are talking about backward bearing of the line ML, you will need to draw the north at the end of the line ML, which is at L here, and you rotate in a clockwise direction from the north towards the line. So that is the angle that we are talking about. Okay, so this angle. Alright. So this angle, how do you get that? Okay, so it will be equals to this angle, okay, plus 180 degrees. Okay, plus 180 degrees. So you will end up with 320 degrees, 30 minutes and 20 seconds. So the backward bearing of the line NL will be equal to 320 degrees, 30 minutes and 20 seconds. And you can look at another example. You are moving from R to S. Okay, from R, okay, going towards S. And you have found out that the backward bearing of the line RS is actually 286 degrees and 9 minutes and 0 seconds. So that means the case you want to find the forward bearing of the line RS. Okay, so the forward bearing of the line RS will be equal to the backward bearing, subtract away 180 degrees. So you end up with 106 degrees and 9 minutes and 0 seconds. So look at this example. You have a line OA and you have a line OB. Okay, the forward bearing for the whole circle bearing of the line OA is equal to 42 degrees, 11 minutes and 53 seconds. The whole circle bearing of the line OB is equal to 230 degrees, 28 minutes and 30 seconds. So that being the case, you can find out the interior angle AOB, that means this angle, okay, or interior angle AOB. Alright, so how to do it? You take the bigger angle, 230 degrees, 28 minutes and 30 seconds, subtract away the smaller angle of 42 degrees, 11 minutes and 53 seconds. Now this is the part where you will have to make use of your calculator in order to do your subtraction. If you want to, you can also do the subtraction manually. Okay. So the difference is that you need to understand that 1 degree is equal to 60 minutes and 1 minute is equal to 60 seconds if you want to do your subtraction manually. If not, you can use the calculator function in order to do the subtraction. So this is how it looks like. Okay, so the big angle subtract away the small angle, and you will end up with 188 degrees, 16 minutes and 37 seconds. So this is also another example where you need to do subtraction of the angle to find the value that you want. So you have again the whole circle bearing OA with a value of 124 degrees, 17 minutes and 51 seconds. And the whole circle bearing of the line OB, which is 230 degrees, 28 minutes and 30 seconds. And now again you want to find the interior angle AOB. That means this angle, okay, this angle AOB. So you have to take the big angle, okay, subtract away the small angle. Right? That means 230 degrees, 28 minutes and 30 seconds, subtract away 124 degrees, 17 minutes and 51 seconds. So if your subtraction is done properly, you should be getting a value of 106 degrees, 10 minutes and 39 seconds. So for this particular case, yeah, the whole surface bearing of the line XA is equals to 42 degrees, 25 minutes and 31 seconds. That means this angle here. The whole surface bearing of the line AB is 130 degrees, 48 minutes and 12 seconds. So given these two pieces of information, you can find out the interior angle XAB. That means XAB, this particular interior angle here, this angle, right? This angle. So how to do it? Firstly, you can try to make use of the forward bearing of the line XA to find the backward bearing of the line XA. Because when you can find the backward bearing of the line XA, you just take the backward bearing, subtract away this particular forward bearing of the line AB, you can get the interior angle XAB. So you can go ahead to calculate the backward bearing of the line XA, and that will be equals to the 42 degrees, 25 minutes and 31 seconds plus 180 degrees. And once you have calculated the backward bearing of the line XA, you take the backward bearing of the line XA, subtract away 130 degrees, 48 minutes and 12 seconds. And your answer should be 91 degrees, 37 minutes and 19 seconds. So again, given this situation where the whole circle bearing or the forward bearing of the line XA is equal to 230 degrees, 28 minutes and 30 seconds, and the forward bearing of the line AB is given to be 94 degrees, 17 minutes and 19 seconds, you can also work out this angle, okay, this angle XAB, okay, the angle XAB, this angle, right? So what you need to do is to go and find out what is the backward bearing of the line XA. That means this angle here. Alright. So once you have calculated this angle, you can take the 94 degrees, 17 minutes and 90 seconds, subtract away this particular angle, then you can get your this angle, the interior angle. Right. So that is the way to do it. Okay. So you go and find the backward bearing of the line XA. Alright, so the backward bearing of line XA, so that means this angle here, this angle, the backward bearing of the XA. So that will be equals to the forward bearing, subtract away 180 degrees. So once you have that, you can take your 94 degrees, 17 minutes and 90 seconds, subtract away this angle. Yeah. So when you do that, okay, your answer should be 43 degrees, 48 minutes and 49 seconds. Let's look at one complete example, okay, for the calculations of the angles and the bearings. Yeah. So in this particular example, there was a traverse that was carried out from point B, okay, to C, to D, to E, to F, to A, and then back to B. Okay, and the forward bearing of the line BC. Forward bearing of the line BC was measured to be 210 degrees, 5 minutes and 10 seconds. Subsequently, all the interior angles, okay, of the angle C, angle D, angle E, angle F, and angle A were measured. Right? So these are all the values. So with all these values, you are required to calculate the forward bearing of the lines CD, DE, EF, FA, and finally AB. Right? So that is what you want to do. So the first step that you can do is to go and calculate the forward bearing of the line CD, given this forward bearing of the line BC, and knowing the interior angle, okay, of the figure at the angle at the point C. Right? So how do we do that? So since you are starting by trying to find out the forward bearing of the line CD, you can just draw a partial diagram that indicates show the line BC and this CD to illustrate your calculations. Okay. So from here, okay, you can actually go and work out, okay, this angle here, which is the backward bearing of the line this BC, okay, backward bearing of the line BC. Alright, so that will be equals to 210, 5, 10, alright, or 210 degrees, 5 minutes and 10 seconds. Subtract away 180 degrees. Okay, so you can get this value. Alright, so that will be 30 degrees, 5 minutes and 10 seconds. And then you have measured this angle. Right, this angle. This angle is measured to be 250 degrees, 45 minutes and 10 seconds. Alright. That actually allows you to find the interior angle, okay, BCD here. Okay, this interior angle. Right, this interior angle. So this interior angle will be equal to 360 degrees minus away the 250 degrees, 45 minutes and 10 seconds. So you get this value here. So this angle plus this angle, then it becomes the forward bearing of the line CD. Right? So the forward bearing of the line CD becomes this angle plus this angle. So that's 30 degrees, 5 minutes and 10 seconds plus 109 degrees, 40 minutes and 50 seconds. So after you have calculated the forward bearing of the line CD to be 139 degrees, 20 minutes and 0 seconds, you can then continue to calculate the forward bearing of the line DE. And again, you can draw a partial diagram, okay, to allow you to see the calculations clearly. Okay. So same thing, you can calculate the backward bearing of the line CD. Okay, backward bearing of the line CD, which is this region here. So the backward bearing of the line CD will be the forward bearing plus 180 degrees. Right, so that's backward bearing. And you are also given, okay, the measured value of this interior angle here, okay, which is 79 degrees, this 37 minutes and 24 seconds. So now if you want to find the forward bearing of the line DE, okay, which from here to here, so you can take the whole angle here, the 319 degrees, 20 minutes, subtract away this region here, okay, alright, that means this, okay, so this, subtract away this one, you get the 239 degrees, 42 minutes and 36 seconds. So in the same way, yeah, you draw a partial diagram again of the lines D, E and EF, yeah. So you make use of the forward bearing of the line D that you have calculated previously. Okay, so you can then work out what is the backward bearing of the line DE, okay, by taking this value, subtract away 180 degrees. Yeah, and again you are given the measured value of the angle at the E. Yeah, and the measured value is 53 degrees, 7 minutes and 21 seconds. So you can actually find out this particular angle here. Okay. Or this angle here then becomes your forward bearing of the line EF. Okay, forward bearing of the line EF. Okay, which is taking the big value, okay, 59 degrees, 42 minutes and 36 seconds. Subtract away the small value of 53 degrees, 7 minutes and 21 seconds. Okay, so you get the forward bearing of the line EF, and you continue. So you do the same thing. Okay, draw the line this EF and this FA. Okay, make use of the forward bearing of the line EF that you have calculated. So again, you calculate the backward bearing of the line EF, which is this angle shaded in the purple here. Okay, 186 degrees, 35 minutes and 15 seconds. And right, you have measured the angle, okay, at this F, okay, to be 309 degrees, 31 minutes and 4 seconds. So you can calculate the interior angle, okay, at this point F here. Right, so you just take 260 degrees minus away this angle, then you get the rate that angle here. All right, yeah, and you can then work out what is the forward bearing of the line FA, yeah, by taking this value plus the backward bearing of the line. So you can do the same procedure for the last line AB. Yeah, so you work out the forward bearing of the line AF. Yeah, work out the backward bearing of the line FA. Okay, work out the backward bearing. Okay, which is this value. This is what you have measured. Okay, and then you take the difference. Okay, that will give you the forward bearing of line A.